Hi everyone. In today's session, we are going to discuss about setting up a network. So as we discussed in previous session, basic of network like what is network, networking, internetwork, then internetworking, then types of network, local area network, metropolitan area network, wide area network, campus area network, wired network as well as wireless network. So if you want to set up a network, so different network components are required like NIC card, network interface card is required. Then media, is cables here either guided or unguided, wired or wireless here. Then network devices are required here. Network device like Cisco device here, router, switch, firewall, access point, WLC. Then we require here end user devices also like PC, laptop, server, printer, IP phone, these devices. So your first network component is NIC card. So NIC nothing but here network interface card. So NIC is the interface between the computer and the network. So if you want to connect any device to the network here, so NIC card is required because without NIC card, you cannot connect device to the network here. So that's why in each device you will get here NIC card. So in this NIC, this is the first type here, which is called as their internal NIC here. These NIC are called as internal because these NIC card are present inside the devices here. So that's why internal NIC. And again in this internal NIC, you will get two types here, wired NIC and wireless NIC. So wired NIC is used for wired network here because we have to use their cable. So that's why wired network here, and wireless NIC is used for wireless network here because without cable here. So that's why we have this wireless network here. For this wireless network, wireless NIC. So in this wired NIC, you will get here this port here. And this port is called as RJ45 port. Register jack 45. And 45 is nothing but a listing number because in this RJ45, there are total 8 copper pins here. So that's why we have to connect here connector here because this cable here. So in this cable at both end, you will get here RJ45 connector. It means when you use your cable, so this is wired NIC. Then wireless NIC here without cable here because wireless NIC having this antenna here. So this antenna will convert analog or digital signal into radio frequency here. So both NIC card are present inside the device. So this signal will be converted into radio frequency here, RF waves here because they are wireless here. So that's why this antenna is used here. These are the types of NIC. First one is internal NIC. So suppose we have this wired NIC here, network interface card. So on this NIC card, you will get this port here, RJ45 port to connect the cable here. Register jack 45. So not only for this device here, you will get in all devices, you will get RJ45 port connected to NIC card here. Because nowadays we are using here Ethernet technology. And Ethernet is nothing but here LAN technology, local area network technology. So when you see the word here Ethernet, it means you have to use your cable. And to connect the cable here, so in this cable at both end, you will get here RJ45 connector. Register jack 45. So here 45 is the listing number. So we know, suppose we have the same type of device, so crossover cable, different types of device straight through cable. So in this cable, you will get here connector at both end here. So that's why this RJ45, it has total 8 copper pin here. So this is called as 8 pin connector. So we have the suppose cable here, either straight through or crossover. So at both end, you will get here RJ45 connector here, which has total 8 copper pin here. So that's why this is RJ45 connector, and you have to connect this cable to the device. Like suppose we have this PC, which having this RJ45, then suppose we have this switch here. Because in all device, you will get here RJ45 port because of Ethernet technology. So that's why you can connect this cable. So this is nothing but straight through cable. Same in crossover cable also. Just only color coding will be different, but you will get here same port here. So you can connect here by using this cable. So that's why in this cable here either straight through or crossover. At both end you will get here RJ45 connector here. So this is also called as a LAN cable, or we can say Ethernet cable here. So that's why we have this wired NIC. So we have to use your cable. So in all device like router here, we have this router. So this is RJ45 port here, which is connected to NIC card here. Then on this switch also, we have this RJ45 port. Same on this switch here, because switch is having different port, and all these are the RJ45. Then on this printer server, you will get register jack 45. So we have to use your cable here. Then by using this cable, we can connect this device here. So that's why this is the example of Ethernet technology, because this LAN is nothing but here Ethernet technology. So nowadays we are using this technology here. So in all device you will get here RJ45 port here in this local area network. So we have to use this cable here, and you can connect this device to the switch by using this cable. And this cable, we know this is straight through cable, but this is called as a LAN cable because we are using this cable in the local area network. So we can say LAN cable, Ethernet cable, but basically this is straight through cable here. And both end you will get here RJ45 connector. So that's why this NIC is called as an interface between this computer and this network here. Because suppose if this device does not have any NIC card, so you cannot connect this device to the network. So that's why device should have at least one NIC card, either wired NIC or wireless NIC, in order to connect to the particular network. Same this router, switch, whatever we have this device. So that's why this is called as an interface card here, network interface card. Because if device does not have NIC, you cannot connect this device to the network here. Okay. Then without NIC card, you cannot access your internet also. So that's why device should have at least one NIC card, either wired NIC or wireless, and both NIC card are present inside the device. So that's why internal NIC. Then there are different name for this NIC card here. If you check in this device, so you will get the name adapter, network adapter, then network interface controller also, LAN adapter, LAN card, Ethernet adapter. So all these are the name of network interface card here. Because in most of the device you will get here adapter name here, network adapter means NIC card. Okay. So that's why this is the first type of NIC, wired NIC. Same if we have this wireless network, like suppose we have this device AP, access point. So wirelessly we can also connect the device here. Same on this device you will get an RJ45 port here. But suppose we have this laptop here, and if you want to connect this device, any device here wirelessly, so inside this device you will get here both NIC card, wired as well as wireless. So suppose this is wireless NIC card here, which having this small antenna here inside the device, and wired also. But when you connect this device wirelessly here, so in that case this is wireless network here. So that's why this is wired NIC here with cable here, and this is without cable here, because radio frequency waves here. So this antenna will convert this signal into radio frequency, and this cable into electrical signal here. So that's why we have this NIC card here. Both are the internal NIC, wired NIC as well as wireless NIC. So that's why we have this wired network and wireless network. These types of network because of this NIC card here. So these are the NIC here, but internal NIC. Then second type you will get here external NIC. It means if device does not have RJ45 port connected to NIC internally, means if there is no internal NIC card. If you want to connect device to the network, so still you can connect device by using external NIC, which is called external NIC here. So that's why externally we can also connect any device to the network here by using this external NIC here. So suppose we have this one laptop here. So in this laptop here, if there is no RJ45 port, but still if you want to connect this device to the network here, so inside this device you will get a USB port here, universal serial bus here. So that's why in this external NIC we have this USB NIC, universal serial bus network interface card. So that's why you will get a USB port here in this device here, USB port here. So you can purchase here second type of NIC, external NIC here. So suppose we have this external NIC here, USB NIC. So in this USB NIC again you will get a two port. So first one, this one is USB cable actually, USB slot here. Then here you will get a RJ45 port here. This is nothing but RJ45 port. So that's why by using this RJ45 to RJ45 to any device here. Suppose we have this switch here. So you can connect this laptop or PC by using this external NIC, because this switch having this RJ45 port here. So directly you can use here straight through cable here. So that's why this is external NIC here, USB NIC, universal serial bus NIC card here, which having these two ports here, two slot, means USB as well as RJ45 here. So that's why externally we can also connect any device to the net. So in this external NIC here, we have this RJ45 ports here, which has total 8 copper pin here. Then this is nothing but USB. So you can connect to this device here. So externally we can connect this PC or laptop to the network here by using this external NIC here. So that's why we have this second type of NIC card here. First one is internal NIC and the second one is external NIC here, because you can see this is cable here, RJ45 end here, and we have this USB NIC, means external NIC here. So externally we can also connect any device. Then there are different manufacturers here for this NIC card. So if you check the status here, you will get different manufacturer also. Like Intel is there, manufacturer, then Realtek, Broadcom, Ralink Technology. So all these are the manufacturer for NIC card here. Then you will get here speed of NIC card here, wide NIC here, because nowadays we know we are using Ethernet technology. So that's why for the Ethernet here you will get different types of Ethernet, because Ethernet is the LAN technology, local area network technology. So that's why in each device you will get RJ45 port because of this Ethernet technology. So that's why here these are the types of Ethernet, like Ethernet. So if device having Ethernet port, so this port can support maximum speed up to 10 Mbps. If device having fast Ethernet port, so speed is 100 Mbps bandwidth actually. Then if device having gigabit Ethernet port, so it can support maximum speed up to 1000 Mbps, megabits per second, nothing but here 1 Gbps, gigabits per second. Then if device having 10 gigabit Ethernet for very high speed data transmission, so the speed is up to 10,000 Mbps, means 10 Gbps. Then nowadays you will get here 40 gigabit Ethernet also for very high speed data transmission here, generally through optical fiber cable here. So that's why we have this 40 gigabit Ethernet also, which having this speed up to 40 Gbps here, 40 Gbps. So that's why these are the types of Ethernet, with actually speed of NIC card here, means speed of RJ45 port here. So suppose we have this one device here, PC, and this device having this internal NIC here inside this device, and we know in this internal NIC you will get this port here, RJ45 port here. So this is RJ45 port, and this RJ45 port here, it can be any port, like it can be Ethernet port, fast Ethernet port, gigabit, like this. So suppose we have this RJ45 port which is Ethernet port here. So that's why the speed for this port is 10 Mbps. If it is Ethernet port here. So we have this device here. Then suppose this device is connected to the router and this router is connected to the ISP side here. Same on this router also you will get this port here, RJ45. This is also and same this port, it can be Ethernet, fast Ethernet, gigabit like this. Suppose we have this gigabit Ethernet. Speed will be 1000 Mbps, for example here. This one is suppose gigabit. So we can connect here this cable here, LAN cable. So this router is connected to ISP side here, to this internet here, internet service provider. So we have this internet, and suppose if 500 rupees to the ISP for this internet connectivity, and right now ISP is providing here 5 Mbps speed, and here we are using this Ethernet port here. It means we can access the full speed of 5 Mbps by using this port, because this Ethernet port can support maximum speed up to 10 Mbps and we have only 5 Mbps, so we can access. But right now suppose for this same internet connectivity, if I 1000 to the ISP and right ISP Mbps, and here we have this Ethernet port. So maximum speed we will get up to only 10 Mbps, not 15 here, because this Ethernet can support maximum speed up to 10 Mbps. So you will not get here full speed of 15 Mbps. But again here suppose if you want to get here full speed of 15 Mbps, so you have to upgrade this port here. So you can upgrade this port to either fast Ethernet, gigabit like this for high speed here. So suppose if I upgrade this port to fast Ethernet port here. So right now this port can support maximum speed up to 100 Mbps because fast Ethernet. So here we will get the full speed of 15 Mbps. But again for the same internet connectivity here, right now suppose if I pay here 5,000 rupees to the ISP, and right now ISP is providing here 150 Mbps. So we cannot get here full speed of 150 Mbps by using fast Ethernet. Maximum speed here up to only 100 Mbps. Again we have to upgrade this port to gigabit here. Then we can access here full speed of 150 Mbps. So that's why as per our requirement, we can take this port on the device here. Same this port you get on this router, switch, all devices here because of this Ethernet technology. So these are the speed of actually RJ45 port here, means wired NIC here. So that's why wired network is faster here. So when you set up a network here, like suppose we have this one router here. So router having this NIC card and this RJ45 port here. Then we have this switch. So switch also having all these ports RJ45. Then we have this PC here. Then laptop devices here. So when you get all this device here, so we know these are the different types of device. So straight through cable here. So that's why at both end here you will get RJ45 connectors. And you can see here this name here, fast Ethernet. It means on this router here, the port is fast Ethernet. It means the speed will be 100 Mbps maximum speed. Same on this switch here, because switch is having different ports here. You can see fast Ethernet 0x1, 0x2. This is the representation here. It depends on slot number and port number actually. Then here gigabit also. So if you require more speed, high speed, so you can connect to gigabit Ethernet also. Otherwise fast Ethernet. So suppose if I select here fast Ethernet, so you can see here speed will be 100 Mbps. Same on this PC and laptop also. You will get here RJ45 port here, and these RJ45 net fast Ethernet like this. So we have this suppose fast Ethernet. So speed will be 100 Mbps. Then to the switch here. Same we have this PC to fast Ethernet to the switch. Then laptop. This RJ45 fast Ethernet to switch. So if you check on this device here, PC. So this is nothing but NIC card here, because we have this RJ45 port here. And you can see these are the 8 copper pin here. So that's why 8 pin connector is required, RJ45 connector here. And this RJ45 port is connected to NIC card, which is internal NIC here. Because we know this port RJ45 is connected to NIC card. And this NIC card is present inside the device here. So that's why you will get this port here. So we can connect this cable here. So that's why this RJ45 port, either it can be Ethernet, fast Ethernet like this. Suppose we have this fast Ethernet. So speed will be 100 Mbps when you connect your cable. Maximum speed here. If it is gigabit Ethernet, same on this laptop also you will get your RJ45 port here. And internal NIC here. If suppose this port is not working, so we know laptop having USB port here, so we can also connect to the network this device by using external NIC here. Or we have this wireless NIC also, you can see this is wireless NIC. So we can also add here wireless NIC here, just we have to turn off the device. Then here we can add this wireless NIC also, antenna. Or this is present inside the devices here, very small antenna here. So that this RJ45 means, and you can, this is wireless NIC. So to access point here, we can connect this device here. Otherwise, cable here. So that's why right now this is wireless NIC, but we require here access point to connect device to the network wirelessly here. So that's why this is fast Ethernet. So right now router can send or receive the data maximum speed up to megabit second here. Same for this switch here. This is fast Ethernet. So speed is 100 Mbps. Or we can connect to this gigabit also. Suppose we have this one more router here, which having this series here, 29 series. Because on this router you will get gigabit port here. So we can also connect router to the switch with this gigabit also. So gigabit 0 by 0, 0 by 1, these are the two ports here, RJ45, which is connected to NIC card here. So if router having two ports, it means two NIC card. If router having one port, means one NIC card here. So this router to the switch here. So we can also connect to the fast Ethernet. If you select your fast Ethernet, so on this switch speed will be 10 Mbps. But on this router the speed is 1000. So you can also select your gigabit here. So here you can see speed 1000 Mbps. But right now router is not, because we know without configuration router will not work. So that's why this is nothing there speed here for this router as well as for this switch here. 1000 Mbps means 1 Gbps here. Okay. So as per our requirement, we can select any port here, either Ethernet, fast Ethernet, gigabit, like this. So actually this 10 gigabit and 40 gigabit, this is actually for optical fiber cable for very high speed. So you will get this interface here. Okay. Interface means port actually on network devices, router, switches like this. Then on this laptop, you will get up to this speed here. So same for, this is actually wired NIC, internal NIC. Same for USB NIC also you will get a speed here, because this is also cable here through this cable. So these RJ45 port here. Again this RJ45, it can be Ethernet port, it can be fast Ethernet, gigabit like this. So that's why you will get a speed of this port also. USB NIC, you can check. So this is RJ45 gigabit Ethernet adapter. And we know gigabit means this port can support maximum speed up to 1000 Mbps, because here we have this gigabit. Okay. So that's why 1000 Mbps are maximum, means 10 Mbps, 100, 1000. Okay. So that's why we have this USB NIC also, you can see. If it is gigabit connector means NIC card here, so it can be acts like a Ethernet, because already 1000. So that's why it can act like Ethernet also, fast Ethernet as well as gigabit also, because you will get all these three speed here, 10 Mbps, 100 and 1000 also. Okay. So that's why we have this USB NIC card here. Okay. So that's why this is nothing there, two types of NIC, wired NIC and wireless NIC. Okay. So on each device there, same in this one, you will get this port here. This RJ45 port. So on this router also, this is NIC card here, network interface card here. Okay. If router having two ports here, you will get a two NIC card here. Two NIC card here. If router having three port, you will get a three NIC card. Same for this device. If two NIC card, means either wired or wireless, so two NIC card. But switch or switch device, we know switch device having different ports here, 24, 96, 48. So that's why for this switch here, you will get all these ports are connected to motherboard here. Okay. one NIC here. Same here, this is wireless NIC. So you can check here status of NIC card also. So that's why in any device here, if you want to check the status of NIC card, either it is working or not here. And you can check your speed also, because we know wired network is faster as compared to wireless network here. So that's why suppose we have this one laptop, and if you want to check the status of NIC card, because inside this device here you will get both NIC card and this one is wireless NIC. So wired NIC means Ethernet here, cable. We have to use here cable here, because you will get here RJ45 port here, register jack 45. So that's why for wired NIC we have this speed here, 10 Mbps, 100 Mbps, 1000, 10,000 like this. So actually wired network is faster because higher bandwidth as compared to wireless NIC. So you will get here Wi-Fi also. So Wi-Fi means wireless NIC, which having less speed, less than Ethernet speed here. So you will get here 400, 700, 800 like this, depending on the NIC card. But actually wired network is faster, because with cable here, you will get speed up to 10 Gbps, 40 Gbps, even 100 Gbps also nowadays. So that's why Ethernet is wired network here. So if you want to check this NIC card here, Ethernet and Wi-Fi means wired NIC as well as wireless NIC. So you have to type here run here. Then ncpa.cpl means network control panel applet.control panel here. ncpa.cpl. So when you type here ncpa.cpl, so you will get this name here Ethernet means wired NIC. Then you will get here Wi-Fi means wireless NIC here. So same in this laptop here. Suppose if I check here NIC card here. So type here ncpa.cpl network control panel applet.control panel. Then click on this OK. Then you will get here NIC card here. So you can see this Wi-Fi not connected, because this laptop is connected to the home router by using this cable. So that's why Ethernet is enabled here. And for this Ethernet, because we know we have to use cable, so that's why on this cable you can see this RJ45 connector here, register jack 45, because this laptop is connected to the router, home router with cable here. So that's why this Ethernet is also enabled here. If I select this option here, then in that case wireless NIC will be enabled wirelessly. Okay. But right now this is Ethernet here, means with cables here. So if you want to check status, so right click here, then click on status. Then you will get a speed here 100 Mbps. Okay. Then you can click on this detail also. You can check actually IP address here. But if you want to check the status of NIC card here, so click on properties. Then click on this configure, and you will get here status of NIC card here. So device type network adapter, because we know NIC card is also called as an adapter here, network adapter. Then manufacturer Realtek, and location PCI bus here, because this is connected to motherboard actually, this NIC card here. And device status here, this device is working properly here, because there is no problem with this NIC card here. Wired NIC is working properly here. Then if you want to check here speed here, so click on this advanced. Then here you will get speed and duplex here. Then value. So by default this is auto negotiation, but we can also select this speed here. So when you select here 1 Gbps, it means you are upgrading this port to gigabit Ethernet. 1000 Mbps means 1 Gbps. Then if you select here 10 Mbps, it means you are selecting this port to Ethernet here 10 Mbps. Then 100 Mbps means fast Ethernet. So that's why as per our requirement we can select here this speed here, otherwise auto here, whatever the port speed here. Then we have to click on this OK. And this duplex mode means you can see full duplex and half duplex. So actually duplex means communication in both direction. So suppose we have this one device here, and this device having this port here. fast Ethernet. And this is nothing but cable here because this device is connected to any other device. And we have this port here, fast Ethernet. So we know the speed will be 100 Mbps here. But if you select a duplex mode here, so duplex means communication in both directions. So here you will get a half duplex and full duplex. So half duplex means either sending the data or receiving the data in both direction here. This is called as half duplex, either sending or receiving, but in both direction, because duplex means communication in both direction. Simplex means communication in only one directional. Then full duplex means sending the data and receiving the data at a time here. Okay, so this is called as a full duplex. So suppose if this fast Ethernet port, if this one is half duplex, it means this right now by using this port here, this device either can send the data or receive the data in both direction here, because this is half duplex here. Or if you select here full duplex here, so right now this device can send the data to any other device, and at a time device can receive the data here in both direction. So this is called as a full duplex. So that's why we have this transmission mode actually, half duplex and full duplex here. Okay. Otherwise by default auto here. Then on the switches also, we can also select a duplex mode. Suppose we have the switch here, but we have to do some configuration command here on the switch. You can also select a half duplex, full duplex. Otherwise this is auto here, or you can also select if you want here. But configuration command is required. So in switch configuration, we will discuss how to set this duplex mode on the switch also. So that's why you can check a status of NIC card here, either it is working or not. So these are the speed here. Same for wireless NIC here, because Wi-Fi is not connected. So if you check here, properties, but manufacturer is different here. Then click on this configure. So here you will get network adapter. Manufacturer is different, dialing technology. And location PCI bus means connected to motherboard. And wireless NIC is also working properly here. Because if I select this option here in this one, if you want to connect this device with Wi-Fi, so in that case you will get here Wi-Fi will be enabled and this Ethernet will be disconnected here. Okay, so that's why we have this. This is wireless NIC, okay? And this one is wired NIC, Ethernet here, because Ethernet means we have to use cable here. Okay? But if you check your status also, so this NIC card is also working properly here, both NIC card wire as well as wireless here. But you will not get a speed here in this one. Okay? But when you connect this device to the network here, then you will get here speed also. So that's why either you can type here ncpa.cpl, or if you want to check the status of NIC card, so directly you can right click here in this option here. So right click here, then click on this one, open network and internet setting. So when you click here, then again you will get this name here, Ethernet. So you can check here Wi-Fi and Ethernet. So click on this Ethernet or Wi-Fi, suppose Ethernet here. You can see Ethernet is connected, RJ45 connector here. Then change adapter option, because we know NIC card is also called as a network adapter. So click on this one, change adapter option, and you will get the same page here. Ethernet and Wi-Fi, wired NIC as well as wireless NIC. So that's why wired network is faster as compared to wireless here. Okay. So that's why we have this NIC card here. First internal means first component is required here, NIC card. Without NIC, device will not connect to the network here. Either it is wired NIC or wireless NIC. Okay. Because this is wireless NIC here. So wirelessly we can also access here internet here. Okay. Then in this switch here you can see all these, because switches having different ports here. So you can see these are the RJ45 ports here, and these are the 8 copper pin here, registered jack 45. So all these are the RJ45 port here because of Ethernet technology, and all these ports are connected to motherboard. But if you check on the router here, you can see this router having only one port here, and this is also RJ45 because 8 copper pin here. So this one is fast Ethernet actually. But we know we have this slot here, and in this slot we can add more number of ports here, Ethernet, fast Ethernet, gigabit, like this. Okay. Otherwise, by default, there is one port here. But in this slot, we can add the port also. So that's why we have this Ethernet, fast Ethernet, gigabit. Okay. This is actually types of Ethernet here. And you will get a speed of NIC card here. Either wired NIC or wireless NIC here. Okay. So that's why in this NIC card, you will get here two types, internal NIC as well as external NIC here, USB NIC. Then on this NIC card here, at the time of manufacturing, manufacturer will assign unique address to the NIC card. Either it is wired NIC, wireless NIC, USB NIC. You will get one address assigned by the manufacturer on this NIC card. And this address will be unique here. So any idea what is the name for this address here, which is required for communication purpose here? And without this address, communication is also not possible in between any device. So what MAC is the address? Name for this address? MAC address. So that's why whatever we have this device, if device is connected to the network, PC, laptop, switch, any device, this device having its unique identity, which is present on the NIC card. So that's why this address is called their MAC address. Identity means of this particular device, which is connected to the network here. So that's why this is called their media, because media means either it can be wired as well as wireless here. So this is nothing but media here, cable or wireless, guided or unguided. So that's why media access control address here, MAC address. Media access control address. So that's why you will get a MAC address of each device here, router, switch, PC, laptop, whatever will be the connected device. Because without NIC card, you cannot connect any device to the network. So that's why on each NIC card, you will get your MAC address also. So here we have to understand, yes, okay. We have to understand this representation also, okay. MAC address. So that's why the next one is media access control address. So MAC address is also called as a physical address, because this is assigned by the manufacturer at the time of manufacturing on NIC card, or we can say permanent address. So that's why physical address, or in networking devices, if you check the name, you will get a hardware address also. So these are the name of media access control address here, MAC address. Then MAC address, if you want to represent here, okay. So actually MAC address, this is 48-bit address, 48-bit. So what is mean by bit here? Any idea? What is mean by bit?
It's a binary like 1 or 0, on or off.
Bit nothing but here binary here. Okay. Means you will get here either it can be 0 or it can be 1, 2 bits here. 0 and 1, right? This is called as a machine language, nothing but here binary language. 1 is for count, means flow of electricity on, and 0 means no flow of electricity, no count, means off here, low bit. Okay. So this is called as a binary language. So if you want to write here this 48-bit, 48-bit. So it can be any 48-bit combination of 0 and 1, because binary is for computer understanding, not for human understanding. But we can also understand. Okay. But device will understand machine language, which is called as a binary. So you can write any 48-bit. So that's why there are different possible combinations here. So first we have to understand this number system. So in this number system, first we have this binary. So in this binary, either it can be 0, because device can understand only 0 and 1 here, this number. Only two numbers here. So that's why base will be 2. For binary, base 2. And this is for computer understanding. So computer cannot understand this number here, 2, 3, 4, 5, then alphabet also, because computer device will understand only the language of 0 and 1, binary language. Then for human understanding, we have this decimal and hexadecimal. So how many digits in this decimal here? For human understanding?
0 to 9.
0 to 9 means total 10 digits. Then in hexadecimal?
16.
16, okay. So that's why this decimal and hexadecimal, these are for human understanding, because we can easily understand any number here, 0 to 9, then alphabet also. So that's why for human understanding, we have this number 0, 1, then 2, 3, up to 9 here. So 0 to 9 means total 10 digit here. So these are for human understanding. Because we suppose we have this number 310. So all these are the decimal numbers, so we can easily understand. So this is for human understanding. But computer will not understand this number 310. So computer will convert either into decimal or hexadecimal. Okay. Sorry, binary here. Decimal to binary or hexadecimal to binary. Because computer will understand only the language of 0 and 1 here. So that's why for decimal here, base 10. Because total 10 digits, 0 to 9. So base will be 10. Then we have this hexadecimal. This is also for human understanding. So hexa means 6 and decimal means 10 here. So that's what total digit you will get here 16. Okay. So in hexadecimal, we have this total 16 digit. So that's why base 16. But in hexadecimal, we cannot write this number 10, 11, 12, 13, 14, 15. Okay. So first we have to write these numbers here 0 to 9 here in hexadecimal also. Because this is also for human understanding. 0, 1, 2, 3 like this. Up to 9. Then after this 9, we cannot write here 10, 11, 12, this like this. This numbers here. Because in hexadecimal, alphabets are used here. After this decimal means after this number 9 here. So that's why A means 10 here. Either capital or small alphabet. Then we have this B. B means 11. Then C means 12. D 13. E 14. Correct. And F 15. So that's why this F means actually 15 here. So that's why you will get this 0 to 15. 0 to 15 means total 16 digit in hexadecimal. So that's why these alphabets are used. So in hexadecimal, you will get 0 to F, in decimal 0 to 9, and in binary 0 or 1. These are the number system. Because computer will understand only the language binary, machine language, and decimal and hexadecimal. This is for human understanding. So we have this base here. So you can see base 2 here. So that's why 2 minus last numbers here 1. Okay. Or directly you can put here 2 minus 1 here. You will get here last number. This one. Same in this one, we have this base 10 minus 1, 9. So that's why you will get your last digit here. Then here 16 minus 1, 15. But we know we cannot write 15. So for this 15, we have this alphabet F here. Okay. So F means 15. You will get your last digit here. But this MAC address, this is 48 bit. And bit means 0 and 1. So you can write any 48 bit combination. Suppose if I write this one MAC address in binary form here, like 1, 0, 1, 1, whatever we have this 0 and 1 combination here. So suppose we have this one MAC address, 48 bit. So this is natural bit number 1, 2, 3, 4, 5, 6 like this. But this is for computer understanding actually. And it can be any combination here, all 0, all 1, what number of combinations here. So this is just representation MAC address. Because computer will understand this binary here. Okay. For human understanding, we have to represent this MAC address in hexadecimal. So total possible MAC address here, because we have this binary, so for binary base 2, because either it can be 0 or 1, and total bits here 48. So that's why 2 raised to the power 48. And you will get a total possible MAC address, which is 281 trillion MAC addresses are possible because of this 48 bit. Total MAC address, 281 trillion. Then we have to represent this MAC address in hexadecimal. So out of this 16 hexadecimal digit, any 12 hexadecimal you can take here to represent MAC address, because MAC address is 48 bit address, but for computer understanding, for human understanding, it is represented as 12 hexadecimal digit here. So that's why we have this hexadecimal digit here. So any idea why we can't write this number here 10, 11, 12 in hexadecimal? Why we have to write this alphabets only A to F, not this number here like 10, 11, this one? Yes, any idea? Because A nothing but here 10 here, but we cannot write 10 here. in hexadecimal. We have to use alphabet here. Because suppose if I take this hexadecimal numbers, okay, any hexadecimal number, suppose here we have this hexadecimal number 1, okay, 1 and 3. So you cannot identify this number actually easily because there are 3 possible combinations in this one. Because this number either it can be hexadecimal digit 1, separate digit here 1, 1 and 3 here. This is the first possible combination, or it can be 11, 3, second possible combination here, or it can be 1 and 13 here. So that's why these are the 3 possible combination here. Suppose if you write here 13 here, if you do not use your alphabet here, if you write here 13, okay? But for the same number here, suppose for this 13, if you use your alphabet 1 and D here, so right now you can easily identify 1D means 1 and 13 here like this. Same in this one for this 11 here. If you write here B here, 11, it means B and 3. So you can easily identify B3 means 11, 3. So that's why these alphabets are used. Because actually in hexadecimal, one hexadecimal digit is equals to 4 bit. So up to this 9 here, you will get here 4 bit. But if you write here 1 0, okay, 1 0 here, actually it means this is 16. 1 0 means this is 16 in hexadecimal, and 1 1 means 17 if you write here. So after this 9 we have to write 10 here, but if you write 1 0 10, so this is actually 16 in the hexadecimal, because here we have this 8 binary bit here, you can see. So that's why we cannot write here 1 0 means 10 11 like this. We have to use your alphabet, because 1 0 means 16 in hexadecimal and 1 1 means 17 18 like this. But we know after this 9 we have to write 10 here. So that's why this alphabet C is used here, A. So here 1 hexadecimal digit is equals to 4 bit of binary. So by using this power table we can easily convert. So we know for binary base 2 here. So we have to write here power table for 4 bit here. Then by using this power table, you can easily convert hexadecimal to binary, binary to hexadecimal like this. So we have this 4 bit here. So first bit you will get here 2 raised to the power 0, then 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3, because these are the 4 bit here, 0, 1, 2, 3. So this is called as actually power table here for 4 bit. So we have these values here. So 2 raised to the power 0 means, because any number raised to the power 0, e raised to the power 0 means 1 here. So that's why you will get here 1. Then 2 raised to the power 1 means 2. Then 2 raised to the power 2 means 4 here. 2 raised to the power 3 means 8. It's 2 into 2 into 2 like this. So that's why this will be double actually, 1, 2, 4, 8. If we have this 8 bit, you will get here 16, 32, 64, 128. In IP address you will get. But in this one we have only 4 bit. So that's why we have this power table for 4 bit. 1, 2, 4, 8. Then you can easily convert. Just we have to remember 1 is for count in this conversion, because in transistor which is present inside the device or logic gate, 1 represents flow of electricity and 0 represent no flow of electricity off here. Okay? So that's why 0 for no count here. So we know 1 hexadecimal digit is equals to 4 bit of binary. So suppose if I take here this first hexadecimal digit 0, and we know this hexadecimal digit 0, this is for human understanding. So computer will understand this binary here, 4 bit. So you can see if you want to convert this 0 into 4 bit here. So right now there is no number 0, because we have this power table value 1, 2, 4, 8. So that's why if there is no number 0, so you have to put here all zeros here. 0, 0, 0 and 0. Then we have the second hexadecimal digit here 1. So in this power table 1 is present here. So that's why just we have to count here 1. So just put here 1 here, because we have this value 1 here. Okay. So that's why remaining bit will be 0 here. So that's why 0, 0, 0 and 1. So this is nothing but binary for this hexadecimal number here 1. Then we have this next hexadecimal digit here 2. So if you convert this 2 into 4-bit here, so this 2 is present here. So that's why we have to count here this 2. It means we have to write here 1 here, because 1 is for count, 0 is for no count. So you have to put here 0, 0, 1, 0. Then if you convert here 3, but 3 is not present in this power table. So actually total addition should be 3. So that's why just we have to add 2 plus 1. You will get here 3. So for this 2 and 1, just we have to put here 1 and 1, because 1 is for count here. So that's why 1 and this 1. 2 plus 1, you will get here 3. And remaining bit will be 0 here. So that's why 0, 0, 1, 1. This is nothing but 3 here. Because you can see this 0 is for no count, no need to count this one. Again 0 is for no count, no need to count this value. 1 is for count, 1 is for count. It means this value here, 2 plus 1. And 2 plus 1, you will get here 3, this number. So this actually total addition should be this hexadecimal digit number here. Okay? Then same for this 4, 5, 6, you can easily convert here, because 4 is present here. So that's why you can write here 0, 1, 0, 0, 4. Then if you want to write here 5, so 4 plus 1, 0, 1, 0, 1. Then 6 is not present here. So 4 plus 2, 6. So that's why 0, 1, 1. 4 plus 2, 0. Then 7, 4 plus 2 plus 1. 0, 1, 1, 1, 7, like this. Then 8, 9. So that's why we can convert any hexadecimal digit here. Then we have this number 9 here, but we know 9 is also not present here. So 9 means 8 plus 1. So we have to put here 1, 0, 0, and 1. 8 plus 1, 9. Then we have this alphabet here, A. So how we can convert this A into 4-bit binary? Because we know this alphabet for human understanding, not for computer understanding. For computer understanding, we have this 1 and 0 language, binary. So what will be the binary for this hexadecimal digit A in 4-bit?
1010.
1010, correct. So we know this A nothing but here 10 here. And if you want to write here 10, so 8 plus 2. So that's why, correct, 8 plus 2 means we have this 8 and 2. Count. The remaining bit will be 0. So 1, 0, 1, 0. Then here B means 11 here. So 11 means 8 plus 2, 10, 10 plus 1. 11. The remaining bit will be 0. 1, 0, 1, 1. Then C means 12. So that's why 8 plus 4, 12. Remaining bit 0, 0. 1, 1, 0, 0 like this. D means 13. So 8 plus 4 plus 1, 13. Then we have this E means 14. So 1, 1, 1, 0. Because 8 plus 4 plus 2, 14. Then F means 15. So that's why 8 plus 4 plus 2 plus 1. Because 1 is for count here. So we have to count all these numbers here. So that's why you will get here 15 here. F means 15. So this conversion is called as a hexadecimal to binary conversion. So just we have to remember one hexadecimal digit is equals to 4-bit of binary here. This is binary. And this one is hexadecimal digit for human understanding, and this binary is for computer understanding. But we have to represent here map. You can see, we know after this 9 here, we cannot write here 10 here like this, because 0 means 4-bit, 4-bit, 4-bit like this. Single hexadecimal digit here up to 9. So 9 means here 1001, 4-bit. 9 means 1001 here. So these are the 4 binary bit here, 4-bit. But after this 9 here, because this is 4-bit here in the binary, but if you write here, if you do not write suppose alphabet here, and if you write here number 10, so this actually 10 means you will get here 8-bit, not 4-bit, because we have this 2 hexadecimal digit 1 and 0. So that's why when you convert this 1 and 0 here, if I write here 1 and 0, so for this 1 here, you can see 0, 0, 0, 1 here. So we have this 0, 0, 0, 1, 4-bit. Then again for the 0, 4-bit here, so you will get here 0, 0, 0, 0. So actually this, if you write here 10, so this is not 10 in hexadecimal, this is actually 16, because you can see we have this power table here 1, 2, 4, 8, 16, 32. This will be double actually. It's 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, and 2 raised to the power 7, 128. Okay. So that's why you will get this one. So if you write here 1 0, because 1 nothing but here 4 bit here, and this 0 means again 4 bit, but actually this 8 bit you will get here 8 bit, and this is nothing but here 16 in hexadecimal. It means if you write here 1 0, it means you are not writing here 10. This is actually 16, and 1 1 means 17, 18 like this. But we after this line we have to write 10 here, not 16 here. If you write 1 0, it means actually you are writing here 16. But we know after this line it should be 10 here after 9. So that's why this alphabet is used there. 1 0 1 0 means 10. Only in 4 bit here. Because alphabet means 4 bit. If you write 1 0, this will be 16 bit here in binary. And this 8 bit means, sorry, 8 bit here, 1 0 means 8 bit, nothing but here 16 here. Because if you write here, suppose 1 1. So if you write here 1, so just you have to put here 1 and this will become 17. So this is not 11. If you write here 11, it means actually you are writing here 17. So that's why alphabets are used, not this number here. We have to use B. And B means 11 here, not 17 here. After this 16 here, you have to write here 8 bit here. Because after this F here, this is only 4 bit. If you want to write here 16, so you have to write here again this number here, 1 0. So 1 0 means 16. So that's why you will get here after F, you will get here 1 0. This is actually 16. Okay. And 1 1 means 17. And this will be continuing. 1 2 okay, means 12 actually. 1 2 1 3 like this. 18, 19, 20 like this. So because up to F here, you will get only 4 bit. And after F, if you want to write 16, so this is 1 0. So that's why alphabets are used here in hexadecimal. Okay. Not this number here, 10, 11 like this. So this is nothing but conversion. But we have to represent MAC address here. So any 12 hexadecimal digit you can select in between 0 to F. So depending on the operating system here, you will get this representation here. So suppose we have this one device here, which having this Windows operating system. And in this device here, if you check MAC address for Windows operating system, so you will get here hyphen symbol here, this one. Only representation is different. Number of bit and number of hexadecimal number will be same. This will not change. If device having Linux operating system, so you will get a colon symbol. If device having Cisco devices, so Cisco is not actually operating system. For Cisco device, the operating system name is iOS, because these are the operating system Windows, Linux. Then for Mac operating system also you will get colon symbol. Okay. But for Cisco device here we have this operating system here iOS, Inter-Network Operating System. It means if you check the MAC address on Cisco device here, like router, switch, whatever we have the Cisco device, network device. So you will get a dot symbol here because this is the operating system for these devices. Cisco proprietary operating system iOS, only for Cisco device, Inter-Network Operating System. So that's why you will get a dot symbol. So we know this is for human understanding, but computer will not understand these numbers here, hexadecimal. So computer will convert into binary. Because in binary you will get a 48 bit. So we have this one MAC address representation in hexadecimal. So these are the 12 hexadecimal digit. Because you can see 2 hexadecimal digit, 2 like this. So that's what total 12 hexadecimal digit. So in this any MAC address here you will get here for devices actually. You will get here byte value. So we have this byte number 1. Then we have this byte number 2. You will get total 6 byte here. Byte number 3, 4th, 5th, and 6th. So can you tell me how many bits in 1 byte? It means 1 byte is equals to how many binary bits here?
4.
4.
8, I guess.
We know 1 hexadecimal digit is equals to 4 bits of binary. But we have this 2 hexadecimal digit. So that's why you will get here 8 binary bit. Okay. So 8 bit. Okay. So that's why 1 byte is equals to 8 bit in the binary. because when you convert, so as it is, you will get here binary bits here. So this 0 means 4-bit here 0000 for computer understanding. Then A means 1010 hyphen. Then 2 here 0010. Then next one is 10001. Then C 1100. Then next one is F 1111. Then hyphen symbol 10001. Then 9 here 1001. Then B 1011. Then next one is D 1101. Then last one C and 50101. So this is nothing but binary here for computer understanding, because we know computer will understand only the language of 0 and 1. Okay? And this is for human understanding, 12 hexadecimal digits. And in binary you will get a 48-bit, because we know 1 hexadecimal digit is equals to 4-bit of binary. Then again here 1 hexadecimal digit is equals to 4-bit of binary. So that's why we have this 8 binary bit here in 1 byte, means 1 byte is equals to 8 binary bit. Second byte here means 8 binary bit here again. Correct here. 8 into 6 here, because we have this 8-bit means 8-bit in one byte here. So that's why we have this total 6 bytes. So 8 into 6 here, you will get here 48-bit. So this is binary here, but we know in hexadecimal we have this total 12 hexadecimal digit here. So that's why this is the representation in binary, and this is for binary for computer understanding, and this is for human understanding, 12 hexadecimal digit. Only representation will be different here, means colon symbol, dot symbol. Same for Cisco device here. We have this 16-bit here, because 4 hexadecimal digit, 4 hexadecimal digit, 4 hexadecimal digit here. 12 hexadecimal digit. Okay? But in binary here, 1 hexadecimal digit 4-bit, 1 hexadecimal digit 4-bit, 4-bit like this. So that's why 16-bit here you will get here. Okay? So in binary you will get here 16-bit, 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 48-bit in binary, and bit 12 here. So that's why we have this representation of MAC address here. In binary, for computer understanding, 48-bit, and for human understanding, 12 hexadecimal digit. So this is the representation of MAC address here. Then if you take any MAC address here, so actually this MAC address is divided into 2 parts again. First 24-bit and the last 24-bit in any MAC address. So we know this is 48-bit here, MAC address. So this is divided into 2 parts. First 24-bit, which is called as their OUI, organizationally unique identifier. So in any MAC address, first 24-bit means first 3 byte, because 1 byte is equals to 8-bit. So that's why first 3 byte represent manufacturer. Means this is for vendors here, and this is unique here for each vendor here. So in any MAC address, first 24-bit represent manufacturer. These are fixed here. Fixed for the vendor. Vendor cannot change, which is assigned by this organization IEEE. So that's why in any MAC address, first 24 bits are provided by IEEE organization, Institute of Electrical and Electronic Engineer. Vendor cannot change. Vendor can change only last 24 bits here, because last 24 bits are called as a vendor specific or serial number. So if vendor can change last 24 bit, so that's why total possible MAC address will be 2 raised to the power 24. and 2 raised to the power 24 means 16 million, and 16 million means 1.6 crore total MAC address here for vendor size here with 1 OUI. So suppose if I check the MAC address of this laptop, okay? So if you want to check the MAC address here, so in this command prompt you have to type ipconfig space /all in CMD command prompt, okay? Or you can also type here get MAC here. So you can check your MAC address of this wired NIC as well as wireless NIC here, okay? So in this command prompt type here ipconfig space /all or get MAC also. So for, in this one you will get here MAC address of this Ethernet, because we know Ethernet adapter means wired NIC. So that's why you will get this name here physical address, because we know MAC address is also called as a physical address or hardware address. So this is the MAC address of Ethernet. Ethernet means wired NIC A0 hyphen, and we know this laptop having Windows operating system. So that's why for Windows you will get a hyphen symbol. If it is Linux operating system, colon symbol. So A01D48C13653. So in this MAC address, first 24 bit, it means first 3 byte here. Byte number 1 to N3. This is called as OUI. And these are fixed. A01D48. Vendor cannot change. Same for wireless adapter here, wireless NIC card. Again, you will get one MAC address here because this is unique here, MAC address. Okay? So that's why we have this one MAC address here of this laptop. So you can easily check the vendor for this device here by using its OUI, because in this MAC address, this OUI is assigned by the IEEE organization for this particular vendor, and you can easily check your vendor also. So we know here this is one just example here, MAC address here, because it can be any number here with one OUI. OUI will be fixed here. So that's why you will get your first MAC address here, A01D48. This portion will not change because this is organizationally unique identifier. Vendor cannot change your first 24 bit, because if you convert into binary, you will get your 24 bits here. Okay? So first MAC address you will get here 00, then hyphen 00 and 00. This is the first MAC address with this OUI. Then second MAC address here, because you will get total 16 million, 1.6 crore MAC address with one OUI because of this last 24 bit. Because you can see we are changing only last 24 bits here. First 24 bits are same in binary and in hexadecimal also. Then you will get here 02, 03, 04 here like this up to 0F. And we know in hexadecimal, F is the last number here. So that's why after this MAC address here. So what will be the next MAC address after this MAC address here? Yes. What will be the next MAC address in this series here?
Is it 010000? Or the middle one 01?
No, only last 2 hexadecimal digit will change here. This one. Because we know in hexadecimal, yes.
Last 2 digits will be 1F.
Okay. So you can see after this one you will get here 10, because this F will become 0 because we have this hexadecimal number 0 to F here. F is the last number. So this is the last number here, F. So after this F, automatically you will get here 0. First number. And this 0 will become 1. 1, 0 like this. And then this series will be continue. And you will get here 1, 1, okay? 1, 2, up to 1F. F is the last number. Then 0, 0, 0, 0, 0, 0, 2, 0. Then this 2, 1, 2, 2, 2F like this. 3, 0. So this actually this 0 will become 1, 2, 3, 4, 5 up to F. Then this 0 will become 1, 2, 3 up to F, F, F. Number of MAC address you will get. Okay. So that's why last MAC address. What will be the last MAC address? in this series?
FFF.
FFF. It means if you put all 24 bits 1 in the binary and in hexadecimal all F here, this will be the last MAC address. Because of this 24 bit here, first 24 bits are fixed. Vendor cannot change here first 24 bit. Vendor can change only last 24 bit. So we have this last MAC address, all F. Last MAC address. In binary, you will get here 1 1 1 1, then here 1 1 1 1 like this 1 1. So all bits are 1 here. And in this one, you will get here all bits 0. First one 0 0 0 like this. All 24 bits are 0. All 24 bits are 1. Then in between this one, we have this total MAC address here. And as we calculated this total MAC address here, because of this 24 bit, 2 raised to the power 24, we have this 1.6 crore MAC address with single OUI. For vendor size here, means these are the total MAC address with one OUI. But this organization IEEE will not provide only it means only last 24 bits here. So if you want to check here the vendor of this device, okay? So you can type here OUI lookup in the browser and easily you can check here. So you have to type here OUI lookup. Then in this OUI lookup here, either you can type here entire MAC address or just you can type here OUI here. Okay? You will get a particular vendor also. So open the browser here. Then type here OUI lookup organization unique identifier. Yes, can you hear me?
Yes, sir. Now you're audible.
So type here OUI lookup here in this browser, then press enter. So here, this one OUI lookup here, scroll down this one. So you will get here MAC address lookup. MAC address lookup here. So click on this one, MAC address lookup. Then here type the, either you can type your entire MAC address or just A01D48 means OUI. Then click on this one, lookup MAC address here. Then scroll down this one. So you will get information about this OUI. So it means IEEE organization has already assigned this OUI A01D48 for this vendor HP. It means this laptop belongs to HP vendor. So vendor cannot change first 24 bit. This is fixed here A01D48. Vendor can change last 24 bit, all 0 to all F. In binary, all 0 to all 1s. So that's why this total possible MAC address here 1.6 crore MAC address here, 16 million. Okay. Then if you scroll down there again, so you can check your MAC address for Windows operating system, okay, by using ipconfig space / all. Then in so that's why this OUI has already assigned by the organization IEEE for this vendor.
Sir, is this the MAC address for all the product of HP? Hello?
So the vendor is HP. So that's why here, same for HP vendor, not only one OUI. This is one example for this OUI,
For all
A0148.
the product of HP, sir, this is the MAC address for all the product. Is this the MAC address for all the product of HP? Product
HP, correct. This one, A0148 OUI. It can be any
for
number.
all the products, sir. For means each and every laptop means
No,
whatever
no,
they.
no.
Hmm?
See, not for every, because if any, not only one OUI, this is only one OUI, A0148. For HP vendor, you will get one more OUI, 0002 A5 also. This is also for HP vendor. Because we know for some vendor 7 OUI, 10 OUI, not only one here. This is just one example for OUI for HP vendor. But IEEE organization will assign different OUI because these MAC addresses are not sufficient. 16 million. Okay.
Correct, sir.
So that's why number of OUI for one vendor. This is one just example. With single OUI, 1.6 crore. Same for like suppose we have this different vendor. Okay? Like suppose Intel, you will get here 00AA02. This is for Intel here. OUI. So that's why this is called as an organizationally unique identifier. This cannot be the same. If you find here A0148 or suppose this one, it means vendor will be HP. This is fixed here because first 24 bits are fixed. So unique identifier. Same suppose we have this one vendor here, Dell for example. So for this Dell, you will get one OUI, not only one here. This is one just example, single OUI like F0 4D A2. You will get a different OUI for Dell here. This is also organizationally unique identifier. Okay. Then for Nortel, okay, Juniper, Cisco, you will get a different OUI. Okay. But not only one here. It depends on the IEEE organization. For different vendor, OUI will be different here. So that's why these are fixed here. This will not change here. Fixed for the particular vendor. Vendor can change last 24 bit here, and it can be any number. And we know this is just one example in this one, C13653, one MAC address, because this MAC address lies between this range. It can be any MAC address here in this one with one OUI. Same with this OUI 0002A5. Okay. Because only first 24 bit will change here in this OUI. Suppose if I write here this OUI for HP vendor here 00, then 02, and here A5. So we know this portion will be same here 0002 A5, and this portion will be same here. Only first 24 bit will change like this. A0 miss. Just we have to put here this OUI, and this number will be fixed. It means with one OUI, these numbers are fixed for the MAC address. 1.6 crore MAC address, 16 million. Okay. So you can last 24 bit vendor specific. So that's why either it is wired NIC or wireless NIC. You will get here MAC address here, which is assigned by the manufacturer. So that's why physical address here. Okay. So this is actually unique identity of that particular device. Like suppose we have this PC. So you will get a MAC address of this device here. So this device PC having its unique identity, physical identity in the network, and this identity is MAC address. Then if router is connected to the switch, so this router having its unique identity of this MAC address here. Means MAC address is the unique identity of connected device. Then for this, suppose we have this router having two NIC card, you will get a two MAC address for separate port. Okay. If router having 5 ports here, you will get 5 MAC address. Okay. Same for this printer server, you will get MAC address. But we have this switch device, and we know switches having different ports here. So for this switch here, you will get one common Ethernet based MAC address here, only single MAC address, because all these ports are connected to motherboard here. Only one MAC address. But for remaining device, whatever will the NIC, you will get here separate MAC address here. Because switch is having different port here, 24, 48 like this. So you will get only one MAC address. And if you check for Cisco device here, like you can see in this one, we have this PC. So for this RJ45, you will get here one MAC address of this device here, media access control address. So actually when this device will send a data, like suppose when this PC will send a data to the switch, so PC will send a data on this MAC address. When this switch will send a data to the PC, so switch will send a data to this actual MAC address here as a destination MAC. Then switch to router also, this MAC address is used. So that's why MAC address is the unique identity of that particular connected devices in the network. So when this devices will send a data, so device will send a data on its actual address, physical address, which is the MAC address. Okay. Same for each. You check here in command prompt CMD. I know this is packet tracer here. So actually packet tracer is simulator Cisco here. So that's why you will get a dot symbol. Otherwise, we know on real-time device here, either you will get a hyphen symbol, dot symbol like this. Dot for Cisco device here, hyphen symbol, colon symbol like this. Same if you check for this switch here. Okay. So for this switch, you will get only one common MAC address for all port of the switch, because we know switch having different ports here. You can see RJ45. So for all this port here, you will get one MAC address here. And this is the base Ethernet MAC address 0002. And we know this is Cisco device here. So that's why actually this MAC address will be in this dot with this dot symbol. This is just general representation here. But actual representation will be here 0002 here. Because for Cisco device, you will get a dot symbol. So that's why you will get here 0002. Then dot. Then next for hexadecimal digit here 4AE1. Dot 4AE1. Then again dot here, next for hexadecimal digit AD93. AD93. So that's why you can see we have this dot symbol for Cisco devices here, router switches like this. So switch having only one MAC address here. Then for this router here, because router is not configured, so you will not get actually MAC address here. But router should be configured. Then you can check your MAC address. So we have this one WAN connectivity. And if you want to check the MAC address of this port here, you can see fast Ethernet. Okay? Because this is the port here, but right now routing is not configured. So that's why for this WAN port, you will not get MAC address. You will get only for fast Ethernet here in this one. If you configure routing protocol also static or dynamic, then you can also check. Otherwise, you will get for this fast Ethernet 0x0. This is RJ45 here, which is connected to NIC. Okay? So that's why if you check here MAC address on the router, you will get a hardware address, this name. So ARP, address resolution protocol. Okay. So this is the router IP address here and hardware address, means MAC address here. You can see with dot symbol for this interface fast Ethernet 0x0, this port here, which is RJ45. Okay. So that's why MAC address is also called as a physical address or five MAC address, 3 port, 3 MAC address. Okay. But for the switch only. So here only MAC address is not sufficient, because we have these devices here and these devices are connected. So that's why on this NIC card here, you will get here MAC address, media access control address here. And we know this MAC address is physical address. Physical address which is present on the NIC card. And this is by default. No need to assign. Okay? 48-bit. But this MAC address is called as layer 2 address here. MAC address is called as L2 address, layer 2. Okay. Layer 2 means in OSI model, we will discuss here 7 layers here. So that's why in OSI model, after IP addressing, we will discuss this OSI model, theoretical model, in which we have the 7 layer: application layer, then presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Okay? So these are the 7 layer. Application means layer number 7, and this physical layer number 1, data link layer number 2, layer number 3, layer number 4, 5, 6, like this. Okay? So that's why MAC address is L2 address, which works on data link layer here. So that's why this is L2 address here, MAC address. But only MAC address is not sufficient for communication purpose, because we required one more address here on the NIC card, layer 3 address here. So what is the name for this address here, which is required to carry the user data, and
IP
which is
address.
logical address? Network layer address. Because this is L2 address here. Because when this device will send a data, so device will send a data on its actual address, which is the MAC address, destination MAC here. Okay? So this is the physical address here. But by using which address here? Logical address is also required here for the device, which is layer 3 address, and this logical address is called as IP address,
IP.
internet protocol address here, which is used to carry the user data. So that's why NIC card should have both address, physical address as well as logical address also. This is called as a logical address because we can change IP address as per our requirement. So that's why this internet protocol address is used to carry the user data from one device to another device on its actual address, MAC address. So that's why MAC address is the unique address here, physical identity, but by using this IP address. So that's why this IP address is L3 address, network layer address, which is called as their logical address. So in each configuration, actually, we have to use IP address only, not MAC address. MAC address is by default in all device here. So when you do the configuration, okay, you can see in initial configuration, we have to use this IP address. Then for this devices also, we have to use this IP address. For this WAN configuration, no need to assign MAC configuration. We have to use only IP address, because by default NIC does not have IP. As per our requirement, we have to assign. So that's why logical address, L3 address here. So that's why NIC card should have both address, L2 address, physical address, means MAC address, L3 address, IP address, to carry the user data from one device to another device. So that's why in this IP address, we will discuss here two versions in details: IPv4, Internet Protocol version 4, and IPv6, Internet Protocol version 6. Then different classification in this IPv4, you will get a class A IP address, class B, C, D, E. Then again representation, binary to decimal, decimal to binary. Then in this IPv6, again binary to hexadecimal, hexadecimal to binary, private IP, public IP, subnet mask, octet format. Because IP address are most important topic for the networking. This is actually base here. Because in each configuration, whatever we have this practical labs in the Cisco packet tracer, in each configuration we have to use IP address, either IPv4 or IPv6. So that's why this topic we will discuss in details. Okay? So in next session we will complete this media part here, okay? Because this is just about NIC here. So in next session we will complete media part, then we will start here IP address here, which is the most important topic here, IP addressing. Okay? And once if you understood IP address, easily you can do the configuration also. Okay? So that's why our NIC is the interface between the computer and the network. It is also known as LAN card or Ethernet card or adapter also. Then this NIC have this unique 48-bit address, media access control address, which is called as a physical address or hardware address. And depending on the operating system, we will get representation, dot, colon, hyphen, like this. And these are the speed of wired NIC. Okay. So that's why we have this first components here. To set up a network, NIC card is required. Without NIC card, communication not possible, because device will not connected here, and each NIC card having MAC address. This is the physical identity of that particular device. So physical address assigned by the manufacturer at the time of manufacturing. But this device does not have any IP address by default. As per our requirement for each device, like we have this PC, because without IP address communication not possible. If you connect the devices, so device is having by default NIC card and MAC address, but communication not possible. So that's why whatever we have this device, connected device in network, like PC, okay, printer, switch, for each device, even for switch here, because we know without IP address switch can work because plug and play device, but we can also assign in initial configuration. So that's why for all the devices we have to assign IP address. So both address is required for the communication purpose, because only one address is not sufficient. With MAC address direct you will not get reachability. IP address is compulsory here, internet protocol address. Okay. So that's why next session here we will start IP address and media part also. So this is just about NIC card and MAC address here, L2 address. So that's why this MAC address operate at layer 2, means data link layer. So that's why this is L2 address, and IP address is network layer address layer 2. So we have this first component here, NIC card and MAC address here. So any doubt in this topic here? So in next session, we will start here IP address here. Okay. First, we will cover here IPv4, all this topic in details here: private, public, subnet mask, octet format, network address, broadcast address, okay, conversion, as well as representation also. Then classification. Then we will discuss here IPv6. Then we will start our practical in the Cisco packet tracer. Okay. So in next session, actually, I will share my contact number. Okay. So from next session, you will get new meeting link and password on your mail ID to join the session. Okay. So in next session, you can join the WhatsApp group also. And in that WhatsApp group, you will get all the study material and link for packet tracer.
Sir, hello.
Yes. Yes.
Sir, I registered yesterday. I didn't got recordings for yesterday's session.
So you can send
I
message
just
to
joined
Vani.
today.
You can send message to Vani ma'am. She will upload record video. And daily you will get on your mail ID. You have to download actually.
Okay, sir.
For previous record video.
Okay, thank you.
And in this Cisco packet tracer, you will share link or we have to install from this
Yes.
on the internet?
Yes. Can you hear me? Furkan?
Yes, we need to
Yes.
install packet tracer online, or you will share some link.
So you can, if you want to download, because first we have to sign up here. Okay. So I will show this one how to download packet tracer also. Directly you can download from Chrome, but you have to sign up. Okay. Or in WhatsApp group directly, I will share this link here. Directly you can download here. Okay.
Okay, fine.
Because in practical, I will show this one how to download packet tracer also. You can download. Otherwise, in WhatsApp group, you will get the link here. Okay. Because for practical, we have this Cisco packet tracer here, and we have a separate session for this packet tracer also. How to connect the device, how to assign the IP address, how to check the reachability after IP addressing. Because without IP address directly we cannot start here practical. Because we know in configuration practical lab we have to use IP address. So that's why IP address is most important topic. So first we will complete IPv4, IPv6, then we will do the practicals here in Cisco packet tracer. Okay.
Sir, can I ask something?
Yes.
Yeah. As you were telling about NIC card types like full duplex and half duplex. So is it necessary when we are connecting two devices, like one, if I have a PC with the full duplex NIC card, and can I connect that to another device which is half duplex device card?
So actually when you set here this speed here, okay. So in this one, this, if you suppose we have this device here. So we have this device here. So if you suppose again we have this fast Ethernet, but right now this one is full duplex, okay? And this one is half duplex here. Okay? So right now this device can send only data at a time or receiving the data. This is the meaning of half duplex. You can set, but if you set here full duplex, so this device, this PC one here, it can receive the data, it can send the data in both direction at a time. Otherwise, auto mode here. Okay? If you do not select here half duplex, full duplex, so directly this device automatically will select here auto negotiation mode here. Even switch also, because you can see suppose for this switch here. Because in switch here we have to write configuration actually. because we have this configuration command and verification command also. But for these devices, there is by default auto negotiation mode. So interface status. So you can see in this switch also, we have this fast Ethernet 0x1 not connected because no device is connected. Then same you can see here auto mode here. Otherwise we can also set here. So this 10 means Ethernet, 100 means fast Ethernet, okay? 1000 means 1000 means gigabit Ethernet. But right now you can see this one is auto here. Same you can set here half duplex, full duplex, but you have to write configuration command. Okay? Duplex mode here. You can also change. Otherwise, this is auto. Switch will also adjust here auto mode, and even devices also. But if you want to change, so on these devices you have to change here. Otherwise, auto here. Okay. Full duplex here, okay? Or half duplex. But generally it should be auto here. Okay. Otherwise, we can also set here full duplex here, because in that case communication will be in both direction, sending the data and receiving the data here in both directions. This is called as their full duplex. We can also say. Otherwise, here by default is auto here in this one. You can check.
Okay, thank you, sir.
Okay.
Okay. So today we'll stop here, guys. You will get new meeting link to join the session from tomorrow.
Sir,
And
what
we will
about WhatsApp group?
Because this is just demo session. So in next session I will share, okay, contact number. So you
Okay,
can
sir.
join the WhatsApp. Okay.
Means sir, class is not started yet. Means our syllabus.
No, it started. Just only 2 days are demo session because sessions are already started here. Okay. Just you will get new meeting link from tomorrow.
Okay, sir. Okay, sir.
Okay, thank you. Cisco Security.
Cisco security we will start after switching topic here, because we know we have these 4 topics here: routing, switching,
Yes.
then security and wireless. So first we are talking about basic of networking. Then after
CCNA.
IP address we will start routing part, routing configuration, then switching and
Okay.
security also. Okay.
Okay.
Because we have this day-wise schedules here in this one.
Okay.
So we will complete all these topics here.
Sir, can you share your number, sir, please?
So in next session I will share my contact number also. Okay.
Monday to Saturday, na, sir?
Monday to Saturday. Okay? Sunday will be off.
Daily 2 hours.
Yes, 2 hours. Because when we started this practical, actually it will take time here, 2 hours. Okay.
Okay.
Because configuration is
Okay,
different.
sir. Okay, sir.
Okay.
Okay. Bye all of you.
Abuse, sir.
Bye, sir. Thank you so much. Bye.
Thank you, sir.